everybody. So in this particular video we'll be talking about the expression of the Coulomb's law, and we'll also talk about what that expression means and how we are going to use it in our further numerical examples. Okay, now so as we have already discussed, Coulomb's law was stated by Charles Coulomb, and it represents the force between two charged particles. Suppose let me take those two charged particles and Q1 and Q2. Let the distance of separation be R, and the force, the electrostatic force, was given by the formula F equals to K Q1 into Q2 upon R squared. Okay, this particular formula only represents the magnitude. We all know that force is a vector quantity, so we'll be needing the direction as well when we'll be talking about numericals, but that we'll be leaving for another video. In this particular video, we'll be talking about this expression and what it particularly means. Now, this K here is known as electrostatic constant. You can also name it as Coulomb's constant in some cases. Now, if we write down the expression further down, it can be written as Q1 Q2 by 4 pi epsilon naught R squared. Okay, so here we see that the K is actually having a broken down formula, and that formula comes out to be K equals to 1 by 4 pi epsilon naught. Okay, now of all the terms 1 and 4 pi, these are constants. All we need to know is what does this particular epsilon naught represent. Okay, now if we solve these out, epsilon naught is a constant, we'll be talking about it. If we solve this particular thing out, you will get the value of K as the magnitude value. I'm not writing any units as of now. It would come out as 9 into 10 to the power 9. Okay, that will be the value of K. Now, the epsilon naught is actually an important thing that you need to understand. Okay, this is known as permittivity of free space. Okay, it has got a value that is 8.85 into 10 to the power minus 12. Without units, I'm just writing the magnitude for the time being. Okay, these are all in SI terms. Now, when you talk about epsilon naught, the name itself says permittivity of free space. What does that mean now? Now, in order to understand the literal meaning of this thing, let me give you an example. So, if I keep these two charges, supposing air is a medium, so there will be a particular force of attraction or repulsion between them. It depends on whether the charges are like or unlike charges. Okay, now, maintaining the same distance, if I place these two charges, suppose in water, okay, if I place the same two charges maintaining the same distance in water, do you think the force would still be the same? Obviously not, right? There would be some changes based on the medium, because water is a different kind of medium, air is a different kind of medium. So based on the medium, there will be some differences in the force, there will be some differences in the magnitude of the force. Okay, now that medium dependency is actually being represented by epsilon naught. Okay, epsilon naught represents how much does a medium permit the electric field to pass through. That is actually a definitive meaning. But for a general sense, in order to understand it very simply, you need to just take it as epsilon naught is a medium dependent factor. Once the medium in which you are dealing the numerical or dealing the formula with, once that medium changes, the epsilon naught would also change correspondingly. Okay, so this epsilon naught represents permittivity of free space, or you can also take it as vacuum. Okay, so whenever we'll be dealing with charges in air or vacuum, okay, whenever we'll be dealing with charges in air or vacuum, that will be 99% of the cases when we deal with sums. So in that particular case, we'll be taking epsilon naught. Okay, because this represents the permittivity in air or vacuum. Now, what would happen if I change this set, or if I take the set to a particular different medium? Let me take the different medium to be water for the time being, just as an example. And now let us analyze how would the formula change. Okay, so now we'll be discussing about what happens when you place the set of charge in a different medium other than air. Okay, so I have already written down the formula. When we keep it in particular medium like air or vacuum, the formula stands as Q1 Q2 by 4 pi epsilon naught R squared, where we have discussed epsilon naught as the permittivity of free space. Now when we talk about a different medium, okay, the medium can be anything. It can be anything other than air. Now what would happen? Now, since the medium has changed, we cannot use epsilon naught in this case. Hence, you cannot write down the expression as k q1 q2 upon r square, because k would represents 1 by 4 pi epsilon naught, and epsilon naught cannot be used in this case. So when you are talking about a different medium, you need to know about two different epsilon. Okay, one epsilon is known as epsilon r. This is known as relative permittivity. Okay, relative permittivity with respect to the medium air. With respect to air, you can say. And one of the epsilon would be said as absolute permittivity. Okay, this is known as absolute permittivity. Okay, now you can be given either of the two when we'll be talking about a different medium. Now, what are the relative formulas between these three types of epsilon? Epsilon naught, epsilon r, and epsilon. First of all, you need to know about their names. This is known as epsilon naught, or permittivity of free space. This is relative permittivity, and this is absolute permittivity. So, absolute permittivity is given by permittivity of free space into relative permittivity of the medium. That's one of the very basic and very general formula that you need to keep in mind always whenever you are dealing with a different medium. So this is the formula that will help you to solve the numerical as a whole. Now when you talk about a different medium, suppose you are given a medium and you are also given the relative permittivity of the medium as epsilon r. Okay, so in this case the force, it might be attractive or repulsive again depending on the nature. That force of electrostatic would be given by q1 into q2 by 4 pi. Since you are given epsilon r, how will we be using the formula? We will be using it as epsilon naught into epsilon r. If you are given epsilon r, you have to multiply with epsilon naught and get the formula q1 q2 upon 4 pi epsilon naught epsilon r squared. Or if you're not given epsilon r, if you're given the absolute permittivity as a whole, then you can directly take down the formula as q1 q2 by 4 pi epsilon r squared, because we can gradually see from here this formula would finally turn out to be what? q1 q2 by 4 pi epsilon naught into epsilon r would give you epsilon, so it's epsilon r squared. So it depends which of the epsilon is given. If you're given epsilon r, just multiply it with epsilon naught to get the particular formula, or else if you're given epsilon, just multiply it in place of, use it in place of epsilon naught. Now when you see this formula and when you check this formula, how are the two formulas related? If you divide this f with epsilon r. Okay, suppose if I take it as f, let me take it as f air and let me take it as f in any different medium. Okay, now if I compare these two formulas, what is the relation between the two formulas? If I divide f air force in the medium air or vacuum by epsilon r, if I divide it by epsilon r, we get the force in the medium. So the force in the medium is given by force in vacuum or force in air divided by the relative permittivity. So actually the force decreases. Okay, so when we dip the medium in a different, when we dip the charges in a different medium, which we generally say as water in this case, the particular force would decrease. Maintaining the same distance, the force would decrease. Or else if you have to maintain the same force, okay, if the question is asked, what should be, if you are asked to maintain the same force in a different medium as well, what should be the distance? Should the distance increase or should it decrease? So since you have come to know, because the force decreases, hence in order to balance the force, in order to keep the same magnitude of the force, what should we need to do with the distance? We need to decrease the distance as well in water or in a different kind of medium. That is how you get the equivalent amount of force. So this is just a normal comparison of force in a different medium and force in air. Okay, that would help you.